Welcome back, reinforcement learning. The navigating with the Q learning, a neural network as a Q function. The topic is navigating with the Q learning topic, the last topic in navigating the Q learning, a neural network as the Q function. We already discussed about what is Q learning, what is the Q function, how to build the neural network for the Q function. Okay, this is the revision version of the Q learning. A neural network as the Q function. Here in this session we are implement the Python code for neural network for the Q function. Here in this session we use the grid world example as a game. In this grid world game, it has a 4x4 grids. It has a agent, wall, pit and goal. These are the parts in the this grid world: agent, wall, pit and goal. Okay, this we are give this environment, this game environment to the input to the Q function. Okay, the Q function input representation is the state of the environment. The state of the environment, we have the 4 elements in this environment. One is the player, means agent, goal, pit and wall. Okay, it is a 4x4 grid world. The each 4x4 grid world is represent the one element of the environment. Here we use the 4x4 matrices to represent the position of the player, the position of the goal, position of the pit and position of the wall in a certain state of the environment. So we have to give this state is the input to the network. So it is give the flattened vector. The flattened vector is the input to the neural network. So we build the neural network. It receives the flattened input as a input to the neural network. This is the 4x4 matrices. So the number of values for the input is 4 into 4 into 4. So 4 means 4 into 4 into 4 means 64 elements we have to give the input to the neural network. So we build the neural network to accept the 64 length of vector as the input. So this is the string diagram of the this neural network. The neural network is implemented with the deep learning frameworks is called a deep Q networks. We are implement the Q function with the neural networks. It is called a deep Q network. This is the string diagram of this function. It has a input layer, hidden layers and output layers. The input layer receives the 64 inputs. It has the 2 hidden layers. First hidden layer contains the 150 neurons. Second hidden layer contains 100 neurons. So after layer 1 input layer, it produces the 150 output, and second hidden layer produces the 100. Last output layer, it gives the number of possible actions. The last neuron gives the number of possible. It contains the number of possible action count of the neurons. This grid world game, we have the possible actions are up, down, left and right. So the output layer produces the 4 only. This is the architecture, the game state. This is the game state. It is give the input to the input layer. It has the 2 hidden layers. The output layer, it gives the Q values for the right, left, down and up. Okay, then this is the PyTorch code for implement this one neural network architecture. The layer 1 64, layer 2 150, layer 3 100, layer 4 is 4. Here 2 hidden layers are used the ReLU activation functions. This is the loss function and optimizer. And we train the model. During the training, we build the instances for each epoch. We create the instantiate the objects for the game, and current state is fed into the Q network, means that is the neural network that implements the Q function, and it produces the output is all possible actions. An action is selected based on the epsilon greedy policy. Here we are using epsilon greedy policy for the exploration and exploitation. So the action is taken in the game and reward and new states are observed. After that we have to update the Q values by using Bellman equation, that is nothing but a updated Q value. Okay, in this updated Q value, we are using the discount factor, learning rates and rewards of the current state, and maximum Q value for the next state. We find this one, we are substituting Bellman equation. Okay, we train this network, this target value, and the process it is repeated. Okay, this is the training process. We are, for each epoch, a new game instance is created and give the input, fed the Q, game state to the Q network, means that is the neural network, and it produces the possible actions, and based on the actions we select the actions based on policy, the epsilon GD policy in this example, and we compute the values and we update the Q values, and this process is repeated during the training process. This is the training. Here we have taken the number of epochs is 1000, epsilon value in epsilon greedy, epsilon is 1.0, and gamma is that is the discount factor value 0.9. Using these values we train our model. The actions, we state the game environment status. We have the three statuses in game, that is the random state, player state, and static states. We have the grid world game is the three states. We already discussed in the previous sessions. We using the state 1, status is equal to 1. We update the we choose the actions using epsilon grid method and take the action based on that policy, and observe the rewards and compute the target Q values and update the Q network and update the state and decay the epsilon. This is the training process. During the training process, we are continue this training process based on number of epochs. This is the entire training process code in PyTorch. Okay, this in training, the last plot is for the first Q learning algorithm, which is clearly down training over the training epochs. Okay, the loss is reduced during the number of epochs. Next one is evaluated and testing. During the evaluation and testing, we take the different modes, game modes we are evaluated. The game modes are the static, player, and random. The static means the player and environment objects like a wall, pit, and goal all are at the fixed positions. The player mode means the player only at random state, remaining all are predefined fixed places. The random place all are at random positions. Okay, we evaluate and tested with the all modes. The final is we conclusion, the loss function typically decreases over the time as the model learns, and this is visualized in the form of the loss plot in the previous diagram. The loss is reduced. This is the testing PyTorch code for this one. And in game mode, this is the last part for the Q learning. In the random mode, the game is random mode, means all are at the random positions. So it is a more complex. This is a more complex one. So in this case, which does not show any signs of the convergence. In random mode, it's not show any signs of the convergence of the losses of the compared with the number of epochs. Okay, thank you. This is the Q learning implementation using neural network.